Let me take the opportunity to greet everybody all over Free State, whoever is listening or in any of the community radio stations, whoever will be watching us on Facebook and other platforms of media, welcome. Let me start with the introductions. My name is Mohapi, and I'm working here in Mutao District as Survey Advisor for Mathematics. And I've got one of potential teachers who's going to help me with the presentation today. I will allow him to introduce himself.
Good evening. My name is Motlengwa Tolang, and I am the head of department for maths in Bloemfontein South High School. Thank you, Ndadimai.
Thank you, Ndadimai. Without any waste of time, let's dwell into the matter for the day. Remember, the main objective for today is to provide the grade 12 learners with a guide on the paper that they are going to write this coming Friday, which is Mathematics Paper 1. They will be writing the paper from 9 o'clock in the morning until 12 o'clock midday. The paper will be 150 marks. Like I indicated, the date will be on the 4th of November, this upcoming Friday. And the paper is set at national level. It's a national paper, unlike the supplementary exam that was set at the provincial level. When a paper is set, it's important for learners to take note of the cognitive levels. Cognitive levels is the level of difficulty of a question. The very easiest of them all is what we call the knowledge questions, which constitute 20% of the paper. Remember, 20% of 150 will give you 30 marks. So 30 marks out of this 150 marks will be cognitive level 1, which we refer to as knowledge. It's a simple, straightforward questions. All that is needed is for learner to recall the principles. Then the second cognitive level will then be the routine procedure. And in routine procedures, routine process will take 35% of the paper. Paper is 150 marks, so 35% of 150 will give you 52 to 53 marks. So 52 to 53 marks will be on routine procedures. Routine procedures, we normally define them as those activities that learners do every day in class. When you are with your teacher in class as grade 12 learners, the daily activities, that is what constitute routine procedures. And as you can see, between routine procedures and knowledge questions, already we've got 55%. So 55% of the paper is, in short, predictable. As you enter the paper, you already know 55% of the paper. So we need to prepare thoroughly to make sure that at least out of that 55% of the paper, 50% you must score. Then the third cognitive level will then be a complex procedure. The level of difficulty is increased. That's where learners, they need to unpack the problem. They need to solve the problem. It means that the question can even include questions covering different topics. So learners need to dissect the problem, break it into smaller pieces, and then start solving it. It's a complex procedure, which constitutes 30% of the paper, and 30% of 150 marks is equals to 45 marks. Lastly, cognitive level 4 questions is a problem for solving. We normally regard them as unforeseen. They are not necessarily difficult, but they are unforeseen. In every paper, there must be those questions that we say, "Ow, it's for the first time that I'm coming across a questions of this type." Those are the cognitive level 4 questions, which constitute 15% of the paper, and 15% of 150 marks is equals to 22 to 23 marks. So it is normal. In every paper, you must have all unforeseen questions. But what is important is that 55% of the paper is accessible for every learner because it's knowledge and the routine procedures. So it's important, very much important, that learners acquaint themselves with the papers so that when they enter the exam room, everything becomes familiar. Nothing should scare them. Thank you very much. Let me give Mr. Mtlengwa next to me here to carry on with the presentation.
Okay, thank you, Mr. Mohapi. As we are about to write our maths paper, we would be specifically focusing on paper 1. And the topics that would be assessed under paper 1. Sorry for that. The first topic that we have under paper 1, which would be algebra, and algebra would constitute of 25 plus or minus 3. That plus or minus 3 means algebra will go from 22 to 28 at most, will range from 22 to 28 at most. And then the second topic that we did for paper 1 would be patterns and sequence. Patterns and sequence would also range from 22 to 28. That is 25 plus or minus 3. That is the second topic that we have under paper 1. And the third topic that we have under paper 1 would be the functions. The functions would be 35 plus or minus 3. That means the functions will start from 32 at minimum and then at most would be at 38. All the functions that we have. And then the financial maths part, the topic financial maths, would also be from 12 to 18 at most. It's 15 plus or minus 3. And then we also have calculus as our fifth topic for paper 1. That would start from 32 at most, it would be 38. That is 35 also plus or minus 3. And then lastly, we have probability. Probability would range from 12 to 18 as well. Minimum 12 and then at most it would be 18. That is 15 plus or minus 3. Now with all being said about the topics that we have, sorry for that, under paper 1, we would first start with the first topic, that is algebra, and then check what does algebra, the compositions of that algebra that we have. The questions under algebra would be simplification and solve for x. That is the first part. And that simplification and solving for x would have plus or minus 3 marks. That is the first question. Like x squared is equals to 2x plus 4, and then solve for x there. Or x squared is equals to 5x minus 4, solve for x there. That is your first question under algebra that has plus or minus 3 marks. And then the second question would be a quadratic formulae. This is where the question that would say solve for x and then x into 3 minus x, that is equals to negative 3. And then the question would have the small llana statement on the other side that says correct to 2 decimal place. This is the part where most learners or the markers would penalize the learners for incorrect rounding off. If you are given the statement besides that question that says correct to 2 decimal place, then that's where you should use your quadratic formulae. And then the third question, we have the quadratic inequality. Quadratic inequality, that's where we have our inequalities. For your inequality, you should have the conclusion. By solving for x only in the inequality will not help the learner. Inequality would need the conclusion. Like for instance, if we have a question that says 3 minus x less than 2x squared, and then solve for x there. You first get the critical values, and then after whatever the method that we have from the school, be it the diagram or the table, for you to get the conclusion. Whatever the method that we use, then you have the conclusion after that.
Thank you, Madam Mtlengwa. Just to add on what Mr. Mtlengwa has indicated, the key in solving equations for learners, we're talking about the quadratic equations. First, ensure that the equation must be written in the standard form. That is very much important. Even the quadratic inequality, every time, ensure that the equation is written in the standard form before you can factorize. The common mistakes made by learners is that more often, especially when you talk of the quadratic inequalities, learners treat an inequality like an equation. It's a common mistake. So it's important that we prepare ourselves properly, learners. We prepare ourselves properly. We know for sure, for a fact, that in this coming exam paper on Friday, we know very well that the third question will be on quadratic inequalities. Let's familiarize ourselves with rules or procedures that must be followed when you solve quadratic inequality. I hope we are clear, learners, because the main objective of this presentation today is to talk to the grade 12 learners to prepare them for this upcoming end of the year exam for mathematics paper 1, which will be written on Friday, so that on Friday, when learners sit for the paper, everything should be familiar. They must be familiar with almost everything. Then they won't encounter problems and they will do well in the examination. Back to you, Ntate Mhle.
Thank you, Ntate Mohapi. After the quadratic inequalities, we also have the set equations, where our learners first, if you are given the set equation, you must first isolate the square root. After isolating the square root, then you square both sides. And then the common mistake that our learners are doing is when squaring both sides. Say, for instance, the other side is x plus 1. If our learners are squaring that side, and then their common mistake would be they square only the two terms in the bracket without multiplying the two brackets. They only have your x squared plus 1 instead of having your x squared plus 2x plus 1. Instead of having the quadratic, they would have the binomial on that other side. That is the common mistake. And then the second mistake would be if the learners are solving the question, that is a set equation. From your final answer, you would have the two values of x. Say, for instance, x is 1, x is negative 4. The two values there, you check, substitute each value in the original equation to check whether the left-hand side would be equals to the right-hand side. If the left-hand side is not equal to the right-hand side, then you reject that answer, then you substitute the other one. If the second one, it gives you the answer, you then conclude by saying, therefore, x is equals to whatever the value that would have that satisfied the equation that you have. That is the set equation. And then after the set equation, we have the exponential equations. Exponential equations, there are two forms of the exponential equations that we might expect. One would be where the coefficient of x in the exponent there is 1. Say, for instance, we have this question here. Say, for instance, we have your 2 to the power of x plus 2 plus 2 to the power of x, that is equals to 20. You might have this as the first example that we have. Then from there, we use the laws of exponents if we are dealing with the exponential equations. Laws of exponents, the first one says multiplying powers of the same base, we add the exponents. Then we revise that for us to get there. Then we'd have our 2 to the power of x multiplied by 2 to the power of 2 plus 2 to the power of x, that is equals to 20. And then from the two terms that we have on our left-hand side, we'd take out 2 to the power of x as the common factor. Then we'd have our 4 as 2 to the power of 2. Then we have 1, that is equals to 20. 4 plus 1 is 5. Then we have 2 to the power of x multiplied by 5. That is equals to 20. Then we divide both sides by that 5. Divide by 5 on both sides. Then your 2 to the power of x will therefore be equals to 4. And then from the laws of exponents, we know 4 is equals to 2 to the power of 2. Therefore, our x would be equals to 2. That is the first question on exponential equation that we might expect. But this is not the only one. This happens when x has the coefficient of 1. But again, x might have the coefficient of 2. 2 to the power of 2x plus 2 to the power of x plus 2. Then we have plus 5, that is equals to 0. We might also have this kind of a question, whereby now we are going to use the K method. 2 to the power of x, or let 2 to the power of x be equals to k. Then now we have our quadratic equation. We no longer have our exponential equation. It will then be a quadratic equation. Quadratic equation, that would be k squared plus 4k plus 5 equals to 0. Then we solve for k in this instance. These are just the examples that we might expect. And then again under algebra, we might also have the unforeseen questions or the nature of roots. Before unforeseen questions, we have the nature of roots. Nature of roots would be plus or minus 9 marks if they are combined with the unforeseen type of a question. The unforeseen type of a question are the questions that Ntate Mohapi referred to as level 4 questions, whereby now it's cognitive level number 4. There are questions that are not taught, but they are combination of the topics that we have. And then the nature of roots, we have the real 2 equal roots, non-real solutions for a quadratic. But for you to get the nature of roots, you must be dealing with a delta, where delta is equals to b squared minus 4ac. Whatever that the roots are referring to would be referring to that delta. For the roots to exist or for the roots to be real, delta has to be greater than 0. For the roots to be unreal, delta has to be negative. Negative because if you put a negative under the square root, then the square root would be a math error. Hence, the roots are undefined if delta is negative, and the roots are defined if delta is positive. That is the first question, or that is the first topic, algebra. Over to Ntate Mohapi to do the second question.
Thank you, Narimjang. Grade 12 learners, we're busy. We're trying to give you the hints on what to expect on this coming Friday. And we also appeal to teachers, please work hand in hand with our learners. Let's support them throughout until they write their final paper. We must guide, support, and even take them into the classroom. Without any waste of time, patterns, sequences, and series. This can be subdivided into 3 sections: the linear and the quadratic pattern. Basically, linear pattern was dealt with in details in grade 10. In grade 11, learners then were introduced to quadratic number pattern. And remember, by definition, a quadratic number pattern is a pattern in which the second difference is common. Meaning, for you to get the second difference, first determine the first difference, and take note that first difference of a quadratic number pattern, that first difference of the quadratic number pattern gives you a linear pattern. Then the second difference will then be common. That is the first part on sequences and series. Secondly, on sequences and series, especially the grade 12 topic, the learners are now being introduced to arithmetic sequences and series. An arithmetic sequence basically is a linear pattern. An arithmetic sequence is a sequence in which there is a common difference between successive terms. So, in the arithmetic sequence, that's where learners should be expected to determine the nth term. Remember the formula for the nth term of arithmetic sequence: Tn is equals to a plus n minus 1 into d. And we also have the formula that we use to determine the sum of arithmetic series. Grade 12 learners, the formula is Sn is equals to n over 2 into 2a into n minus 1 multiplied by d. Or sometimes if you break it down, you have the first term and the last term in the brackets, then the formula will then be Sn, which is equals to n over 2 into a plus l. This formula of a plus l is a formula we use to determine the sum of arithmetic series if the first and the last term are known. The previous one, where I talked of Sn, which equals to n over 2 into 2a plus n minus 1 into d. That's where you have at least 3 terms. They are given. Out of the 3 terms, you are able to determine the first term, even the common difference. Then you can also, in one way or the other, be able to determine the number of terms that are being added. Because when you use the formula Sn is equals to n over 2, that n represents the number of terms. How many terms are you adding up? So, if there are 5 terms that you need to determine the sum of thereof, it means n will be equals to 5. In short, grade 12 learners, know what each letter represents in a formula. If you have Tn is equals to a plus into n minus 1 into d, know what does Tn represent. Know what does n represent. The a, even d. So in short, d is the common difference. The common mistake or the common confusion that grade 12 learners normally experience is that they confuse N and TN. That is the common mistakes. So it's important that teachers please explain clearly the difference between TN and N. If I were to explain in short, I would say N basically it indicates the position of a term in a sequence. If we talk of T20, it means there is a sequence. That term occupies the 20th position in that sequence. If you talk of T5, in that sequence, that term occupies the 5th position. That's why I say in the formula of Tn, N represents or indicates the position of a term in a sequence or in a series. Whereas Tn, let me talk of Tn. Tn, we normally call it a general term. It is there in the sequence, but its position is unknown. I'm not sure whether it's term number 80 or 85, but it is there in the sequence. Its position is unknown. Therefore, such a term, we call it a general term, which we denote by Tn. The main difference between Tn and N is that N indicates the position. Tn, it is a term which is there in the series, but its position is unknown. Common questions under arithmetic series. You might be given 3 terms. Then the question then say, determine the next 2 terms. It will probably be stated that you've got the sequence 2, 5, 8. Write down the next 2 terms. Those are the common questions that we can get. Determine the nth term of the pattern. The nth term, basically, we are referring to the general term. And for you to determine the general term, you must know the value of A, which is the first term, and the common difference. The nth term will always be expressed in terms of N. Let me explain it again. Tn, which we call the general term, will always be expressed in terms of N. It is a general term. So once you are expected to determine the general term, we expect your answer to have, or the expression to have N, because it's Tn, sometimes referred to as the general term. Again, under arithmetic sequence, let me talk of the difference between a sequence and a series. Because once we talk of a series, it means you start adding 2 plus 5 plus 8 plus and so on. That is what we call a series. So once you start adding the terms, then it means there going to be a time where we have to determine the sum of that series. And earlier on, I talked of Sn, sum of the series. And it's important that teachers, as we prepare our learners for the end of the year exam, give learners activities where A, N, and D are known. So they need to work out Sn. Again, give them activities where Sn is known. They can work out the value of N or whatever, any other variable. So as we prepare learners for the final examination, let's expose them to variety of questions asked in different forms. Because if you expose your learners to one type of questioning, should it happen that in the exam there is a different type of, the question is asked differently, your learners will struggle, your learners will perform poorly, and we do not want that. We care about each and every learner. No learner should be left behind. So it's important, it is our responsibility as teachers to prepare our learners in totality for all different types of questions. Again, maybe I should talk about the geometric series before I can talk about the sigma. A geometric series, learners must be able to know the difference between arithmetic and geometric. Arithmetic, remember I said, it's a sequence in which there is a common difference between successive terms. A geometric sequence is a sequence in which there is a constant ratio, which we denote by the letter R, between successive terms. To determine D in arithmetic, normally we say T2 minus T1, T5 minus T4, T10 minus T9, as long as it's a difference between successive terms. But to determine R, which we refer to as the constant ratio, we say T2 divided by T1, or T5 divided by T4, as long as it is a ratio between successive terms. So, even in a geometric series, once the statement stated that the pattern that is given or the series that is given is geometric, it's important for learners to first determine R. A normally is the first term, it's easy to find. And remember, when we talk of the geometric series, know the formulae that are associated with geometric. Differentiate the formulas, arithmetic and geometric, different formulas. Please show your learners all the formulae that has got D refers to, those are the formulae that belongs to arithmetic, and those that have got R, it's geometric. For instance, the nth term of the geometric will then be given as Tn is equals to AR exponent n minus 1. Sn, the sum to n terms of a geometric, Sn is equals to A into R exponent n minus 1 all over R minus 1. Let's familiarize our learners with all those activities. While still busy with summing a geometric series, we have two types of sequences. We have a divergent and a convergent series. A divergent series, every time you add the next term, you get a totally different answer. You add the next term, you get the totally different answer. But in a convergent series, as you add the next term, you find the sum approaches a certain number. The sum will get closer and closer to a particular number, but it will never reach that number. So that's when we talk of a convergent series. And normally we have a convergent series when R is greater than -1 and less than 1. That is the key condition for us to have a convergent series. Learners, for us to have a convergent series, R must be greater than -1 and less than 1. This is basically the rule for that constitute a convergent series. Once we have a convergent series, what comes along with a convergent series is sum to infinity of a series. And remember, sum to infinity. Sum to infinity is given by formula A over 1 minus R. So to determine the sum to infinity, you must know the value of A, you must know the value of R. Because it's a geometric R, T2 divided by T1, A normally is the first term. Let me talk to teachers again. As you prepare learners, teachers, give learners activities where A and R are known. So learners must work out Sn. Again, give learners activities where sum to infinity is known. Then they must either work out the value of A or the value of R. Expose your learners to questions of different forms. What is of utmost important? Earlier on, I talked of the convergent series. For a series to converge, we said R must be greater than -1, but less than 1. Sometimes a question can be asked differently to say, for which values of x will the sum to infinity of the series exist? Once we talk of a sum to infinity, then it means that series must be convergent. So it means for us to use this formula, sum to infinity is equal to A over 1 minus R. R must definitely be between -1 and 1. So once R is greater than 1, we cannot use the sum to infinity. And that's where most of our learners commit mistakes, to use sum to infinity and where R is greater than 1. And then they forfeit marks. Lastly, under patterns, sequences, and series, let me talk about bookwork. If we talk of a bookwork, basically we're referring to the proof of, we're talking about the proof of formulae that needs to be calculated. For example, we know the formula for sum S n of a geometric a into r exponent n minus 1 all over r minus 1. We must be able to derive the formula. We must be able, as creative, be able to derive the formula. Even the formula for arithmetic, Sn equals to n over 2 into 2a plus n minus 1 multiplied by d. We must be able to derive the formula. That is what we constitute bookwork. And in paper 1, maximum marks for bookwork can be 12 marks. So let's get ourselves ready. This is, in short, patterns, sequences, and series, and what to expect under this topic. As we cross over to the next topic, I want to hand over to Mr. Thola Motlengwa.
Thank you again, Ntate Mohapi. The next topic would be functions again. Like we indicated that the functions would be 35 plus or minus 3. The topic functions can be subdivided into the following functions. We have the linear function that is mostly dealt with in grade 10. That can also be the straight line function. Y is equals to mx plus c. For the linear function, y is equals to mx plus c, where m represents the gradient of the function, and then c represents the y-intercept of that function. X and y would be any point on that function here, f, if the function is given in terms of f. And then if m is positive, we know that our function would be an increasing function. If m is negative, then the function would be a decreasing function. We also have the quadratic function. Quadratic function would also be referred to as a parabola. Quadratic function, the standard form, y is equals to ax squared plus bx plus c, where again a in this function would also determine the shape of the function. If a is positive, the function would be concave up. If a is negative, the function would be concave down. And we also have, because it is the quadratic, it has the turning point. And the letter C in that standard form would represent the y-intercept. Parabola, because it's concave up and concave down, it has that point that is referred to as the turning point. Some questions would refer to it as the maximum or a minimum, depending on the value of A. Now, how do we get the turning point in a quadratic that is given as ax squared plus bx plus c? We say the x coordinate of the turning point is equals to negative b over 2a. Then we get the x value of the turning point. That x value then would be substituted into the original equation to get the corresponding y value. By doing that, you would find your x and y coordinate of that turning point. And because it is the parabola, the quadratic function, that has the axis of symmetry. The axis of symmetry would be the line that divides the graph into two equal halves. And for you to divide the parabola into two equal halves, you would have to draw the vertical line through the turning point, meaning the equation of the axis of symmetry of parabola would be the x coordinate of the turning point. Whatever x value that you have on your turning point there would represent the x or the axis of symmetry of that parabola. Say, for instance, we have the parabola that has the turning point at negative 2 and 4. That negative 2 on that turning point would be the equation of the axis of symmetry of that parabola. X is equal to negative 2. That is the equation of that. Again, the parabola can be given in the form y is equals to a into x plus p all squared plus q, where p and q represents the coordinates of the turning point and a is the shape of that turning point. That is the other form of a parabola. And then thirdly, we have the hyperbolic functions. Hyperbolic functions, y is equals to a over x plus p plus q, where a again represents the shape of the graph, or a determines the shape of our graph, and then p and q are the asymptotes of that function. But please do remember that when the question says determine the asymptotes of the given function, you are not supposed to give them in terms of p and q. You give them in terms of x and y. x is equals to 2, y is equals to 3, if that's the case. So the asymptotes in the hyperbola would be given in terms of x and y. And then there are questions where hyperbolic function is not given in the standard form. Please, whenever you have the hyperbola that is not given in the standard form, before you can attempt to answer any questions, rewrite that hyperbola in the standard form first. Then you can attempt to answer the questions. And the hyperbola also, like the parabola that we have talked about, it also has the axis of symmetry. Axis of symmetry, that line that divides the graph into two equal halves. Axis of symmetry of a hyperbola would be a straight line, but it will no longer be a vertical line like it did with the parabola. Here, axis of symmetry would be plus or minus because we have two of them, one increasing, one decreasing. The increasing one would be a positive gradient, the decreasing one would have the negative gradient. With the increasing axis of symmetry, the gradient is positive, then the way you did it, Skolon Salona, you can even use that method to find the axis of symmetry, because there are a lot of ways to find the axis of symmetry, the equation of axis of symmetry. That is your hyperbolic function. And then we also have the exponential functions. For the exponential function, the standard form we know from grade 11, because exponential functions are mostly dealt with in grade 11. In grade 12, that's where the exponential functions are dealt with, and then we introduced the log functions from the exponential functions. That's when we dealt with the inverse functions, saying that if the original function is an exponent, then the inverse of an exponent becomes the log. If the original function is the logarithmic function, then the inverse of that logarithmic function becomes the exponential function. And again, with the inverse functions, that's where you interchange both your x and y. Whatever that we had as the x value on the original function would be the y value when we go to the inverse function. And both functions are behaving the same way. If the inverse is decreasing, it means the original function was also decreasing. If the inverse was increasing, then the original function was also increasing. And decrease and increase, we use that, or we check that by the value of b. If b, whatever the function that you might have, f of x is equals to b to the power of x. If x is an exponent, that means that function there is an exponential function. B, the base of that exponent, determines the shape of that graph. If b is a number between 1 and 0, if b is greater than 0 but less than 1, then the function would be a decreasing function. And if b is a number that is greater than 1, then the function would be an increasing function. For the exponential function and the inverse function of that, which is log, there won't be any movement of your exponential function, meaning your exponential function would also have the horizontal asymptote at y is equals to 0, and then it would also cut the y-intercept at positive 1. There won't be a movement for you to get the inverse function of that. And then, again, under the functions, we might have the mixed algebraic functions. That's where now the questions of the interpretations would come in, where the functions are mixed. That's where the questions of determine the coordinates of the point of intersection of f and g, provided that you are given the two equations. F of x is equals to x squared plus 2x plus 3. G of x is equals to 2x plus 1. Then determine the coordinates of the point of intersection. At that point of intersection, that is where the two equations are meeting, and that's where the two equations are equal. Only at those 2 points. Again, the question of an interpretation would be, determine the values of x for which f, if f is given as your parabola, determine the values of x for which f is increasing, or determine the values of x for which f is decreasing. Those are the types of questions that you might expect. And the products as well. F of x multiplied by g of x is greater or equals to 0. F of x multiplied by g of x is less or equals to 0. If you are given the products of two functions that are less or greater than 0, then it is advisable to use different colors on your graphs so that you can check their signs. Remember, f of x is greater than 0 above the x-axis, and f of x is less than 0 below the x-axis. So you use the same logic to write the signs on the function and then check where you get the product that is less than 0 or the product that is greater than 0. That is our functions, and those functions constitute plus or minus 35 plus or minus 3. 35 plus or minus 3. Those are the functions. Over to Ntate Mohapi for the next question, if Ntate Mohapi can add anything on the functions again.
Thank you, Ntate Mklengo. If I were to add anything on functions, I would say learners must be able to sketch functions. If we talk of quadratic function, hyperbolic function, exponential, or the log, learners must be able to sketch those graphs. Secondly, if those graphs are drawn, learners must be able to determine the equations of those graphs. Those are the two scenarios. And we know for sure every question when it starts is either you draw or the graph is drawn. And if the graph is drawn, it is the learner's responsibility to determine the equation of that graph. And for you, one important aspect on functions is that learners must know the characteristics of each function. Once we talk of quadratic function, we know there is a turning point. Once we talk of hyperbolic, we know there are two asymptotes. Once we talk of exponential, there is only one horizontal asymptote. It's important for learners to know those basics. Thank you, Ntate Mklengo.
Thank you, Ntate Mohapi. And then we can then move to the fourth topic of paper 1. Paper 1, fourth topic would be financial maths.
Thank you.
Thank you.
Thank you, Ntate. Financial maths. It's a topic that started in grade 10. It carries about 15 marks, like we normally say 15 plus or minus 3, meaning it will range from 12 to 18. Minimum 12 marks, maximum 18 marks. It's a topic that requires learners to understand the language. What are the key concepts in financial mathematics? Simple and compound decay. Simple interest, compound interest. Sometimes if you talk of the decay, it means the value of the property depreciates. That's where the formula, you'll see it will have a minus. If it's a simple interest depreciation, then it will be A is equals to P into 1 minus IN. If it's a compound depreciation, sometimes refers to as the reducing balance method. Reducing balance method. The formula is A is equals to P into 1 minus N exponent N. Common questions here, especially when we come to the calculation of N. That's where what we talked about earlier in functions, where learners were introduced to logarithmic functions. Meaning learners now have the skill to solve an exponential equations where the bases are not the same. And they will solve it by changing from exponential form to log form. Same principle can also be asked, where learners will be expected to determine the value of n, where n is an exponent. So that will require learners to have that foundational knowledge, background knowledge of converting an expression from exponential form to log form. Because n will be an exponent, and for them to solve n, they'll have to convert from exponential form to log form. Straight line depreciation, simple, that's the one, the formula A is equals to P into 1 minus IN that I talked about it earlier. Then I talked about the reducing balance, sinking funds. Sometimes, as we are dealing with finances, we come up with lots and lots of scenarios, but there can be a situation whereby a businessman or whoever, the owner of the company, have a machinery and he wants to replace the machinery in 5 years' time. So to make sure that the business does not collapse, he needs to come up with a plan to ensure that At the end of the 5-year period, if the machine is new, you buy it now, 5 years later, it means the machine will now no longer be that useful. We need to put money aside so that when we put that money aside, we ensure that in 5 years' time, that is the money that will be used to buy a new machinery. That is what we call the sinking funds. Effective and nominal interest rates. Learners must be able to convert effective to nominal and vice versa. Take note, learners. The question paper has got a formula sheet, but this formula for converting effective to nominal and vice versa is not provided in the formula sheet. So it means that formula learners must know it by heart. As for other formulae, compound depreciation, whatever, simple straight line, those formulae are provided in the formula sheet. But this one, converting effective to nominal or nominal to effective, learners must definitely know the formula by heart. Annuities. We've got the different ways of saving. Remember, in compound, you take, let me make an example. Take 500,000, you invest it, you'll get it after 5 years. So that's it will increase according to whatever interest rate that will be there. But when we talk of the annuities, annuities involves regular payments. In annuities, we involve regular payments. There is a certain amount of money that I save every month so that after 10 years from now, I can use that money to do any other thing. And that formula has got X, where X refers to that regular payments. Formulas are there in the formula sheet. So it's important that learners familiarize themselves with the formula sheet. Teachers, let's guide our learners. Let's show them which formula is relevant under which circumstances. Future value annuities, that's when you start saving. You will need the money in 10 years' time. So you start saving, then you talk of the future value annuities. But the present value is when you need the money now. I need to buy myself a house, or I need to buy myself a car. I need the money now. So I'll go to the bank, borrow the money from the bank, and then use the money to purchase a car or whatever property that I need. So present value, you need the money now. But for future value annuities, that's where we start saving so that the money can be accumulated after a certain period of time. This is, in short, financial mathematics, and I'm not sure if you have anything to add, but it's important for learners to know what each letter in a formula represents. Thank you, sir.
Thank you, Ntate Mohapi. To add on what Ntate Mohapi said when it comes to the annuities, there are keywords that would refer to the present value and the future value, like the loans and you winning a lump sum of money and then investing it in a bank and expecting the bank to give you a frequent and a fixed amount of money per month or over a fixed time. If it's fixed time, it's either it can be per month, per quarter, per semi-annual, or per year. That is our fixed interval, and that amount also has to be a fixed amount for it to be referred to as an annuity. That amount cannot differentiate. That amount cannot differ from this month and then the following month. That is that regarding the annuity. Then we can move to the second last topic that we have. Second last topic would be the calculus, differential calculus. Calculus, like we indicated when we started, it has 35 plus or minus 3 marks, and it starts first with the first principles and the rules of differentiation, and then the average gradient, either at a single point or between the 2 points. Now, we know the formula for a first principle. First principle formula, f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. We know that formula, and first principles, if we were to talk about the first principles first principles can be asked under different conditions or from different graphs. It can be asked from the parabola, or determine the first principles if f of x is equals to ax squared plus bx plus c. That is the first one. And then the second one would be the first principles. If we are given the cubic, f of x is equals to ax cubed. Bear in mind that for a cubic function, it would only be ax cubed. It will not have any other terms after that cubed. And then we also have the hyperbola a over x. Determine the derivative from the first principles of f of x is equals to 1 over x. That might be the example. It can only go from 1 over x only, negative 1 over x. It will not have any value after that fraction. And then we also have f of x that is equals to any constant. F of x is equals to c. And then from first principles, the word first principles, some questions might be determine the rate of change from first principles, determine the derivative from first principles, determine the gradient from first principles, determine the slope from first principles. All those words, they mean the same thing, first principles. And then we also have a gradient under calculus. Find the gradient using the differentiation. The gradient at x is equals to 1. The gradient at x is equals to negative 2. Once it says the gradient, it means we differentiate. And we differentiate using the three rules of differentiation. The first rule is the power rule. Power rule says, given that f of x is equals to kx to the power of n, where k can be any constant, n might be the exponent of that n. Therefore, f prime of x, or the differentiation of that, would be kn x to the power of n minus 1. Therefore, you only multiply the exponent and the constant, and then the exponent minus 1. And then we have the second rule, that is the linear rule. Linear rule says f of x is equals to kx, then the differentiation of that would only be k. And then we have the constant rule, f of x that is equals to any constant, f of x is equals to c or k. Then the differentiation of that would be 0. And for you to use the rules, there are three things to avoid. You should simplify your whatever expression or the equation that you have. Before you use the rules, you must first avoid having any root. If you have the root, then you use the laws of exponent to avoid that root. You should also avoid having x or a variable that you are differentiating in the denominator. Using that, you can use the fractions from grade 9. And then we must also avoid having any bracket. X plus 1 all squared. If I were to differentiate that, I would first avoid that bracket of x plus 1 squared. Then those are the things you should avoid by all means before you can start using the rules. And then we have the average gradient at that specific point, because the gradient and the differentiation is one thing. After differentiating, you can substitute your whatever value of x that you want the gradient at. And then we have, after first principle rules of differentiation, we also have the cubic functions. Cubic functions would be plus or minus 17 marks in the paper. And the cubic functions, after cubic functions, we have the application of differential calculus. And the application of differential calculus, that's where most learners are not attempting that question. I'll give that to Ntatemo Happy to explain that application of calculus. I would only do the cubic function and then I'll give to Ntatemo Happy for that. For you to attempt the question of a cubic function, you should know the characteristics of that cubic function, know how to sketch the cubic function, know how to interpret or know how to find the equation if the cubic function is drawn for you. Ntatemo Happy.
Thank you very much, Dr. Mtlengwa. When coming to application of calculus, maths is very much theoretical. Now, this is the concept where we want the application of calculus. It can appear in different forms. Volume of cylinder, we can have a rectangle, we can have word problems. The variety, we've got different varieties. And more often, that's where the high order questions are asked in mathematics. The high order, more often, the high order question, the cognitive level 4 questions, they come from
application.
The application of calculus. I think time is against us. Let's finish off with probability.
Thank you, Ntate Mohapi. And then the last topic that we have for paper 1 would be probability. Probability has 15 plus or minus 3, meaning at most probability would go up to 18. Minimum would be 12. And then the probability would start with the probability that we dealt with in grade 10, of which in grade 10 we did the Venn diagrams. And then from those Venn diagrams, that's where different types of events were explained. The mutually inclusive events, that's when there is an intersection. Mutually exclusive events, that's where there is no intersection between the two events, if there are two events A and B. And then we also have the tree diagrams that were dealt with in grade 11. The tree diagrams also comes in two events, the dependent events and the independent events. And then we have the complementary events as well. After the diagrams that we have the contingency table. Contingency table, and then lastly, counting principles. Counting principles, it's from grade 12 only. These other ones are from grade 10, grade 11, and grade 12. Then lastly, it's counting principles. Counting principles, in how many ways can the letters of the word Neo be rearranged? In how many ways can you peg 12 books on a shelf? 5 history books, 5 maths books, and 2 life science books. That is your counting principles. And from that counting principles, again, you should be able to read the question clearly and then understand what is it that you are asked to do before you can attempt the question. In all this probability, because probability uses a lot of English, independent event, dependent event, and all those, you should read the question clearly before you can attempt to answer that question. That is the paper in all. That's where the paper ends. Over to Ntate Mohapi again.
Thank you, Ntate Mtlengwa. Let me thank the listeners from all over the community radio stations for listening to this session. We hope that the learners have learned something. Teachers, remember, learners rely on you for your guidance and support. Let me take again the opportunity to thank my friend here, Ntate Mtlengwa, for helping me to present this session. Thank you very much. And learners, remember, when you go for exam, make sure that you are relaxed, arrive in time, have enough equipment, a pen, calculator, ruler, everything. Be self-sufficient in terms of equipment. Have everything that you need. Make sure that you are calm and your mind is sober. You are calm and your mind is sober. You do not have to rush. You relax. When the paper is given to you, ensure that you use that time effectively to try and establish which questions are easier, so that when you start writing the paper, you start with the easier questions. From me, Mohapi, I wish you all the best, grade 12 learners. Thank you for being with me. Thank you for being with us during this session. Thank you very much.
Thank you very much, Ntate Mohapi.